All right, here's your riddle. Among my siblings, I am the thinnest. I am in Paris, but I am not in France. Who am I? Well, you are the letter I. The letter I. In Paris, but not in France. That's kind of a lame one. Anyway, I wanted to start off today by talking about a little bit about what we've done so far before we get into what you see here as vectors in section 9.4. Chapter 9, you guys are going to be learning, you already learned about polar. You learned about polar coordinates, how to graph a polar function, how to convert between rectangular and polar. And then, so that was 9.1 and 9.2. We're skipping 9.3, and 9.4 and 9.5 are all about vectors, another use of trig, which you'll see actually more in the next lesson than you'll see in this lesson. But nevertheless, 9.4 we talk about vectors. I wanted to start off by defining what a vector is and making sure that, I want you to make sure that you memorize this definition, or that you just really memorizing it by understanding it. And if you're in physics, then that should be no problem. But a vector is a quantity that has both magnitude and direction. If you remind me in class, I'll show you the clip from Despicable Me that talks about where this one character by the name of Vector has this kind of a funny little part in that movie. So I do have that in class. So remind me and I will show it to you. So a vector is a quantity. Well, what kind of quantity are we talking about? Well, commonly we use vectors to describe, let's say, like an airplane flying through the air. The magnitude of the airplane would be the speed at which the airplane is flying, and the direction would be obviously the direction that the airplane is flying. So we can use vectors. What you see here is like a ray, not like a ray, but it is a ray. It's a directed line segment that has a tail. Let's do that too, because we're going to be referring to the tail of a vector as the initial point of the vector. Okay, oh, there, now you can see it. And the tip of the vector is where the vector ends. And this directed line segment has an arrow, but it doesn't keep going on forever. It stops right there, but the arrow represents the direction at which that quantity is either traveling in, or the force that's being applied to that whatever. Like if you're pushing a box to the right, then you can show a vector. I'll do this off to the right. If you're pushing a box to the right side, then let's say I'm pushing a box, and I can push the box at a magnitude of 10 newtons. Now, if you're in physics, that'll make sense to you. And let's say you're stronger than me, and you can push the box in the same direction, let's say 13 newtons. And so we would use a vector that is longer than the vector here to represent a stronger force that's being applied to in the same direction, let's say to the same thing. So we can use vectors to describe the force that's being applied, or the speed at which something is traveling in, and whatnot. But I also wanted to talk about the different forms in which we can write down what a vector is. So this first video is all really about giving you guys kind of like a heads up on the terminology and what we can do with vectors. So if we draw a vector, this vector here, if we start counting from the tail as if the tail were at the origin, we go to the right 1, 2, 3, and we go up 1, 2, 3, 4, 5, and we can express the vector u as the letter U with the little half arrow over it. And you'll notice in the book that the book makes these letters bold, but it's really hard to draw on your own, making some things bold and some things not. So we'll use that little half arrow to represent a vector. And so we can use the letter U to represent the vector. We could also use what we call the component form. We'll get to that in a little bit, where you just really just write the vector in terms of an ordered pair. From the tail, you go 3 to the right, and then from that point you go 5. You go in the second number here would be, if it's positive, you go up in that direction, as if you're just plotting an ordered pair. So from the tail, you go 3 to the right, 5 up, and you plot the tip, and then you just draw an arrow. Okay. So vector v can be expressed as a letter, or with a little half arrow over it, or with little brackets like we did with vector u. over 5 and up 3. So we have the vector u, or v, would be 5, 3, characterized by the components 5 and 3. So we can add vectors also. Okay, so if we add vector u to vector v, the main thing to remember here is what you see right down here. What you want to remember is tail to tip, and you may, if you're in physics, you've heard that before. Tail to tip is really, really important. You cannot add two vectors unless you put the tail of one to the tip of the other. So you should realize here that we put the tail of vector v to the tip of vector u. And once we did that, then if we want to add u plus v, then we just draw a vector from the tail of vector u all the way to the tip of vector v, and that's u plus v. And so if you think about this in terms of something that would make sense to you, if an airplane is flying, let's say u, vector u represents the speed and direction of an airplane, and let's say that or anything in flight, let's say it's 100 miles an hour, let's just say. And then you can see vector v actually does have the same length as vector u. So let's just say we have a 100 mile an hour wind traveling in this direction, you know, kind of up 3 and over 5 direction. And then what direction and speed would the airplane actually be flying in? Well, if you have kind of a tailwind here, as you can see, that vector v would represent kind of a tailwind. I mean, it's pushing the airplane a little bit faster. Well, vector u plus v would be the actual speed and direction of the airplane. So this purple directed line segment, this purple vector, represents the actual speed and direction of the airplane, given that it's traveling 100 miles an hour in kind of like northeast direction, and then the wind is pushing it also northeast, but a little bit further east. Anyway, u plus v would be how you would express the speed and direction of that airplane. And that's called the resultant. Okay, let's actually write that down. That's the resultant, or the result of combining the two vectors. That's called the resultant. Okay, so we're going to be talking a lot about that in the next section as well. And one thing I didn't do is show you is that if you do add two vectors together, you didn't even need to draw them. If you were to count from the tail of vector u to the tip of vector v, let's do that. 1, 2, 3, 4, 5, 6, 7, 8. So 8 to the right, and 1, 2, 3, 4, 5, 6, 7, 8 up, then it's the same thing that you would get as if you just added the respective components of each vector. So u plus v, vector u plus v, can be obtained by just adding the x component, or the horizontal component, 3 plus 5, you get 8, and then you add the vertical components of each vector, 5 plus 3, and you also get 8. Okay, and we could talk about the length of the vector, and we'll do that a little bit later. Okay, but that's vector u plus v. So easy to add two vectors together, and I'm going to have you guys try that right here. We'll do this u minus v later on, and all these other ones later on, but I want you to try just this guy right here. Okay, just try u plus v, just to make sure you've got it. Pause the video, and you can do this all in your head. But pause the video, I'm going to show you the solution right now. U plus v is equal to adding the components 4 plus negative 5, comma negative 3 plus 1, negative 3 plus 1. And so 4 minus 5 is negative 1, and negative 3 plus 1 is negative 2. So that's the answer, and hopefully you got that. So you can see how easy it is then to add two vectors together when they are in component form. Okay, and then another thing you can do is just you can subtract vectors as well, as long as you subtract the corresponding components. And so u minus v would be equal to 4 minus negative 5, comma negative 3 minus 1. And so we'd get the vector 4 minus negative 5 is 9, and negative 3 minus 1 is negative 4. Okay. Now, interestingly enough, what do we do when we have this number out in front of the vector? Well, the number in front of a vector, that actually has a special name. I wish I knew where that name came from, but I don't. Maybe ask your physics teacher. Where does that number come, or the name for that number come from? It's called a scalar, and this is called scalar multiplication. Well, 3 times u, and we're using a different u obviously in this problem than we did in the original one, but u and v are normally what we kind of normally use as letters for representing vectors. But when we multiply a scalar by a vector, we multiply the scalar just like we distribute. Just like if these were parentheses, we would distribute using kind of like the distributive property. And when we multiply 3 times 4, we get 12. And when we multiply 3 times -3, we get -9. Well, what did we do here? What does that mean? Well, for -3, if we look at this, let's kind of do that out here to the left. For -3, if we take this vector and we go out to the right 4, 1, 2, 3, 4, and down 3, 1, 2, 3, then we have this vector right here, for -3. Okay, that's the vector for -3. Okay, fine. Well, when we multiply it by 3, basically what we're doing is we're extending the vector by a factor of 3. And so you see that we got 12, -9, so let's just count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we see here, where is that? There it is. So we see that we took the vector for -3, multiplied it by 3, and what did that do? It increased the length by a multiple of 3. Okay, over 4 and down 3, over 4 and down 3, over 4 and down 3. So basically we just multiplied it by by 3, and we got the vector 12, -9. So we just tripled its length, and so forth. Anyway, 2u minus 3v. Go ahead and pause the video and try that one on your own. We're going to use the u and v from this problem right here. U and v right up there. Okay, again, pause the video. See if you can get the same answer, and then we'll start a new video after this one. Okay, so 2u minus 3v is 2 times u, which is 4, -3, minus 3 times v, and v is -5, 1. Okay, so 4, -3 would be 2 times 4, -3 would be 8, -6. And then what I'm going to do is I'm going to put plus here, and I'm going to make things both of these positive, or I'm changing the sign here. So we have -3 times -5 is +15, and -3 times 1 is -3. So I like to add better than I like to subtract. And 8 plus 15 is 23. -6 plus -3 is -9. And there you go. So again, there's your almost 13-minute video. And it should give you a really good idea of what vectors are, how you can manipulate vectors. This is kind of an algebraic approach to vectors combined with a geometric approach. And then we'll get into some more stuff in the next video.